Welcome to Mini Maths at Virtual School Victoria, where we do a lot of maths thinking in a little bit of time. Today's big idea is, where have our numbers come from, and why is our number system based on groups of 10? Here you can see different ways of organising 10 objects. Now, let's think about a long time ago when people started to become civilized and live in groups for their survival. They were collecting things, growing things, keeping animals, so they needed a way of keeping track so things didn't get lost or go missing. Now, in the early days before counting was invented, people used their fingers. They'd match one sheep to one finger, another one. When they counted 10 and they ran out of fingers, they would find a way to help them remember. Sometimes this was a notch or a tally mark. Sometimes they would pick up something from the ground, like a stick or a stone, to help them remember they've counted 10 sheep through. Now, each sheep is matched to each finger. When we run out of fingers, we pick up a stick and we put it aside. Then we start counting again, and then we might pick up another stick. If one stick represents 10 sheep, how many sheep do 2 sticks represent? So the shepherds use that strategy to help them count through. Look at this and see how many sheep have been counted. This shepherd has counted 10, 20, 30, 40. 1, 2, 3, 4, 5, 6, 7. 40 plus 7 is 47 sheep. Did you guess that? Now, that's another way of showing 47. So it's 4 tens and 7 ones, or 4 groups of 10 and 7 groups of 1, or just 40 plus 7. Now, as the tribes grew bigger and more civilized, there were many more things to count. I wonder if you can have a look at this and see how many sheep have been counted through at this point. Pause the video if you need to. Well, it got very busy with the sticks, and it could easily be that the shepherds ran out of sticks. So they would pick up something like a stone or find something to represent that there were 10 sticks counted. So 10 sticks can be shown with a rock. And we know that 10 tens are 100, so that's 100, 200, 210, 220, 230, 240, 250, 1, 2, 3, 4, 5. There's a little sheep trying to get away. So there were, through the gate, 255 sheep, and the shepherd would remember that because these items represented that number of sheep. Here is another way of showing that. Now let's see if I can get those sheep back in here for you. That's a bit better if you were trying to get away from the screen. Now, 200 plus 50 plus 5, there were 255 sheep counted. Now, our number system has developed to the point where we know the value of something by the position it has in the number. So 5 single sheep would stay in the ones column. Every time we had a group of 10, it would go into the tens column, and every time we had a group of 10 tens, it goes into a hundreds column. So you can see 255 is organised that way. Let's have a look at how the different number systems represented those counting ideas. I thought the Egyptian system was very interesting because it got to 9 and then it thought of a different symbol to show a group of 10 and another symbol to show a group of 100. And I thought the Mayans had an interesting system. as well to show tens and to show hundreds. Another day we might talk about Roman numerals because that is interesting, but the reason the number system evolved the way it did, imagine writing your mobile number in using Egyptian counting numbers or even the Romans numeral system. It would be very tricky indeed. Now let's get back to the idea of digits versus a number. A digit has no value because it doesn't belong anywhere. It's fairly random, but once we organise these digits into a place value column, they make a number. So the number 4,379 is made up of 4 thousands, 3 hundreds, 7 tens, and 9 ones. So you can see the pattern. 10 of those is worth 1 of those. 10 of those is worth 1 of those, and 10 of these is worth 1 of those. And this goes on forever and ever and ever. Now let's have a look at another way of the place value chart. And here's another way of showing that each column is 10 times greater than the previous. And the numbers just keep growing and growing and growing. Now, numbers in our number system can be shown in many different ways. Can you see the correct representation for 4,379? Pause the tape if you want to help yourself think a little bit. Now, let's look. 4,000 plus 300 plus 70 plus 9 is perfectly correct. 4 plus 3 plus 7 plus 9 equals 23, so that's a long way off 4,379. Then you can have 4 groups of 1,000, 3 groups of 100, 7 groups of 10, or 9 groups of 1, and that makes 4,379. And here you've got 4,000 plus 300 plus 9, that equals 4,379. And what we really have here is 37 tens, which is the same as 370. And of course, the last one does not make sense. Now, let's think about what you know about our number system. Our number system is based on groups of 10 because we have 10 fingers. And every time we get a group of 10, we have to find a way of representing it with something else. Numbers are organised in a place value chart. The place of the number gives its value. That's called positional value. And when we have a group of 10, that group is placed into the column on the left. So our numbers in the columns grow bigger by a factor of 10, and there are different ways to represent the same number. Those are important ideas. For example, here we have 357, and there are at least 4 ways of representing 357, including with materials. But I am sure if you thought about it, you could find many, many more ways. Now, the history of number is very fascinating, and I would highly recommend that you find these videos and spend a few minutes watching them to learn where our number system comes from, why we work in a base 10 decimal system, and how we can use this information to help us learn about maths. Thank you very much for watching, and we will see you next time.